Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exam to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone. It was really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother, I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary, that is the students' doubts gets cleared and everything else. So today I came down to the XLR office to collect my certificate. So I got to know about what other courses XLR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens. And they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews and how you should be approaching to companies, your resume building, and there were so many things which XLR is going to help you in, and they are ready to give you all the knowledge required even if you are a beginner. So I really felt good about this visit, and I would really recommend XLR to everyone who's listening to this, and also to all my friends, that I had a very good experience with XLR, and I would suggest you to experience the same. Thank you.
Hello everyone, my name is Satish and I am from Swami Vivekananda Institute of Technology. I am here to share my experience about XLR program. I took part in the XLR program that was conducted in the last month about the mobile app development using Flutter. What I liked the most about this session was the trainer started from the scratch. That means even the beginner who don't know about the basics of the program, even they can learn the most from this program. It gave me hands-on experience by developing a project which was the final outcome. Thank you XLR for giving me this opportunity, and I would also recommend all my friends to take part in the XLR programs. Thank you.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person, where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course, and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching, and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course, and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works. And it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exams to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you XLR
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped. So I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came from for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you XLR for giving these courses. I learned lot of from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone. It was really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother, I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary, that is
Good evening, everyone. Am I audible? Just let me know. Okay. All right. So yesterday we started with cryptography, one of the important fundamentals, okay, if you want to learn what blockchain is. Okay. So what we studied, that cryptography is just a science. It's a art of secret writing. Okay. Why? Because in the world, because internet is open. Internet is really open. So if I'm sending let's say a very private message to someone, so I want that only that person can see it, should see it. Okay, so that means that person is an authorized person, and there should be a confidentiality between us. Okay, so there should be no third person, okay, allowed to see that message. So cryptography provides confidentiality to the data. Confidentiality means where apart from the authorized party, no other person can see the message. Okay, so that's what cryptography is, the art of secret writing. And then we saw that there are two types of cryptography, symmetric and asymmetric. Okay, so what is symmetric? Where we use only single key. I'll recap. I'll share my screen. Just let me know if it's visible. I think it's visible. Yes, I guess it's visible. Okay. So we have seen in symmetric cryptography, in symmetric cryptography, okay, the person has to lock the message. Person has to lock the message with a key. Suppose this is again Alice. Alice has a message M. Okay, and then this message has to be logged. This message has to be logged. Okay, with a key K. I'm writing key K here. Okay, so this will be used by here. Okay, then we get a message which is known as ciphertext or the encrypted text. Okay, this will be received by whom? By Bob. Now Bob will have to unlock this message with the same key. So Bob will apply decryption, will unlock this lock. Okay, with the same key. With the same key. Okay, and then the ciphertext will be converted to message back. Okay, so it's a reversible process. Encryption and decryption is a reversible process. You can encrypt and then you can decrypt it. Okay, so this is important. This is because suppose there's a third party who wants to see this. Okay, suppose this is I. So they can only see this ciphertext, which is not interpretable. Okay, so this is what cryptography is. But we have seen the problem lies with this key because it's a single key. So if anyhow this key is in the hand of this attacker, they can decrypt the message. Also, I told you about this brute force attack, permutations and combination. Okay, so symmetric cryptography, I also told that it's still used because there are advanced symmetric cryptography, like someone said AES and DES. Okay, but asymmetric cryptography is I mean, it's not the latest. It's still 1970s, 80s concept, but it's the one that's being used right now. Okay, even in blockchain we use asymmetric cryptography. So now let's go to asymmetric cryptography. Very important. Okay, if you want to take screenshot, just take it. I think we have already took the screenshot yesterday only. Okay, so I'm rubbing this. Oops. Now let's focus on asymmetric cryptography. Here we have two keys, guys. One is known as public key, and other is known as private key. Okay, I'll show you. So suppose this is Alice again. Okay, Alice has a message M. Alice has a message M. Okay, leave that. I'll explain with another example. Yeah. So it's a story, guys. Okay, so listen to this story very carefully. Suppose again this is Alice, and on the other side of the internet we have Bob. This is Bob. Now, suppose Alice said, Bob, I have to send you a message. Alice has to send a message. So I'll put this arrow in this direction. Alice said that, Bob, I want to send you a message. So Bob said, okay, send me. But Bob said, don't use symmetric cryptography. So Alice said, okay, so then what we use? So Bob said, we will use asymmetric cryptography now. So Alice will say, okay, and how we do that? So Bob will say that I will create two pairs of keys. Bob will create will create a pair of two keys. One is known as public key and other is known as private key. Public key, let's denote it by, let's say, EB. B means Bob. Public key of Bob. Similarly, Bob will create a private key of himself, which is DB. Okay, see, it's for everyone, not just for technical students. It's for everyone. It's really easy. Okay, so Bob will create a pair of two keys, which is a public key and private key, which belongs to Bob only. Public key of Bob and private key of Bob. Alice will have different public key and private key. Alice will have its own public key and a private key. That's why I've written B here. B means Bob. That this key belongs to Bob and this private key belongs to Bob. Alice will say, "Oh, you created both the keys. Then how will I encrypt the message?" Alice will say, "How will I encrypt the message?" So Bob will say, "I'll send you my public key." Bob will say, "I will send you my public key and you do the encryption." Alice will say, "Oh, that's a new way." So Bob will say, "Yeah, because I want that only I can able to decrypt that message using my private key, because these two keys, if I write it here, where should I write it? Here, these two keys, EB and DB, are computationally calculated with each other. They are computationally calculated with each other. That means if you want to unlock the public key, you need their private key. That means if you want to unlock the Bob's public key, you only need you only need private key of Bob. So EB and DB are computationally related to each other. Okay, so what Bob will say? I'll write it here, EB and DB. So Bob will send this over internet. Okay, Bob will send his public key on the internet. Now Alice will receive it. So Alice will have two things here. I'll make this arrow. So Alice will have two things here. First, message. We have a message, and then Alice will be having the public key of Bob. EB. This is small b, okay? This E is big and B is small, okay? I think we all have studied these things in mathematics as x1, x2. So these one, smaller one, okay? So B is smaller one that depicts the name. Okay? So I guess you guys getting an idea what I'm trying to say. So E and small b. Now again, Alice will do the encryption. So she will apply ciphertext is equals to encryption of message. Listen to my words, okay? Don't go to formula right now. Encryption of message. Encryption of message. E means encryption. Encryption of message using public key of Bob. Using public key of Bob. Okay. Now Alice will send this to Bob. Ciphertext. Okay. Now Bob responsibility is to decrypt it. So okay, so this is known as encryption, I'll write. This is encryption, and now we will do decryption. So I'll do it here. Okay, I'll do it here. So Bob will have ciphertext, which is E B of M. Encryption of message using public key of Bob. Now Bob will do decipher or decryption. Decipher. They are just the Greek word. So Bob will apply decryption algorithm. Decryption of ciphertext using private key of Bob that only belongs to Bob and to no one else. You can just imagine that you guys have a lock, and that lock will be locked with a public key. But if you have to unlock it, then you have to use a private key, and that public key and private key are computationally linked to each other. Okay, they are linked to each other. All right, so you can only decrypt Bob's public key with Bob's private key only. It's not like that you can decrypt Bob's public key with Alice's private key. That doesn't happen here. Okay, if you open it, so D of DB, E of EB of M. Now I told you they are computationally calculated, so they will cancel out with each other and we'll get the message M. We'll get the message M. Okay, so I'll tell the story again. So Alice wants to send Bob a message. Okay, Alice wants to send Bob a message. For that, Bob will create pair of keys, which is public key and private key, EB and DB. Now Bob will send his public key to Alice. You can see public, it's public, it's for public. Okay, it's for public. All right. So now Alice will have this public key of Bob. Why? The reason is because this public key can only be unlocked with Bob's private key. Can only be. Okay, with no other key, with only private key of Bob. So that's the idea of Bob. Okay, that's the idea of Bob. So now Alice will encrypt the message using Bob's public key and it will send it to Bob. Now Bob will apply his private key to decrypt it. Okay, now very important thing that this private key should only belongs to Bob, no one else. Otherwise, any person can do it. Okay, any person can do it. Suppose there's a hacker. There's a hacker. I'll make it a bit short. Suppose there's a hacker who also got this message because this internet is open, so he or she can also see this message, the hacker. So hacker will also get this message. See, now hacker will, suppose this is Mantave is the hacker. So what Mantave will do? Mantave will apply decryption, decipher is equals to decryption of ciphertext. I'll write the whole thing, E of B of M. So now how Mantave will decrypt? Mantave will need private key of Bob, which he doesn't have. Listen to this very carefully, guys. How will Mantave will decrypt the message? Because for that he needs Bob's private key, but Bob's private key belongs to Bob only, no one else. So let's say Mantave tried to decrypt it using EB only, EB by EB, which we have seen in symmetric cryptography. One key. They will not cancel out with each other, so it will not get decipher. So this is how asymmetric cryptography provides more security to the data, more confidentiality to the data. I think it's clear. Asymmetric cryptography, because this is important to understand digital signature, where that's the new concept. Okay. Any doubt? Let me just check some doubts. Just let me know if any doubt in asymmetric cryptography. No doubt? It's clear? It's easy, right? Not so complicated. Okay. All right. So we have seen that we have maintained the confidentiality. Confidentiality is maintained. If you guys want to take a screenshot, just take it. Don't take this one. Wait. I'll rub this thing, then you will take. Now you guys can take it. Oops. Yeah. Okay, I'll write it here computationally. Really calculated. Okay, now I'm rubbing it. I'll rub this side right now, okay? The upper one. Now, we have seen that it is providing confidentiality. It is providing confidentiality. Now, there's something which is known as authentication. And guys, if I tell you this, asymmetric cryptography doesn't provide authentication to data. It doesn't provide authentication to data. The reason, what is the reason? I'll tell you. Okay, I'll tell you the reason. Okay, now what I'll do, I'll rub this thing because it's really important to understand everything from scratch, how really it works, on how we are securing the network, the identity of a person. Okay, now suppose this is Mantave, who is the evil person. What Mantave did, listen, please, okay, focus on this right now. It's really interesting. Suppose Mantave impersonated. You know what impersonation is? Stealing someone identity. Mantave impersonated. Let's say this is actually Mantave who is just taken the identity of Alice. Okay, Mantave has taken the identity of Alice. All right, it's not actual Alice. Okay, Behrupia. If you guys know Hindi, I don't know what we are. Doppelganger. Okay, not a doppelganger actually, just a fake identity, impersonation. Now again, I'll create Bob on the other side. I'll create Bob on the other side. Now suppose again Alice wants to send message to Bob. Bob will have two keys, EB and DB. EB means public key, DB means private key. Okay. Now EB will be sent to Alice, or actually Mantave, who is behind it. So Mantave will be having a message M and public key of Bob. But Bob is seeing what? Bob is seeing that Alice is sending the message, not Mantave. This is what Bob is considering right now. Suppose Alice sent a very inappropriate message to Bob. Okay, Alice sent a very inappropriate message to Bob. Okay, so what? First, let's do the encryption. So C is equals to encryption of message using public key of Bob. Public key of Bob. Okay, now this will be sent to Bob. Okay, the ciphertext. Now Bob will receive it. Bob will do decipher. Okay, which means encryption of message using public key of Bob and let's say DB. So it will cancel out and let's say the message Bob got message. Suppose now the message is very inappropriate. It's really vulgar. Okay, it's not a good message. And even if you say bad words, okay, on well, let's say any social media platform, it's a crime. Okay, anyone can sue you for that. I have seen example when I was working in cyber cell, just a small word and that person was called up to the cyber cell. Okay, so suppose Alice impersonated by Mantavya, he sent a inappropriate message or a vulgar message to Bob. Now Bob will directly go to the court or let's say cyber cell and will complain against the Alice. Now Alice will say, I haven't sent this message. Okay, so what is something that will prove the identity of Alice? We have to see, we have secured the messages. You guys can see messages secured, ciphertext. But what about securing the identity of a person? What about securing the identity of a person? I think you guys must be getting what I'm trying to say. We have secured the message, but what about the identity of the person? Here, Mantev has impersonated Alice. Okay, but right now Alice will be called to the cyber cell. Okay, so now that's why I said that authentication is not maintained. The identification of that person, the authentication of Alice is not maintained using asymmetric cryptography. Not with even symmetric cryptography. Okay, so we have to protect the identity of Alice. Okay, otherwise anyone can impersonate her and send the message. Okay, now to solve this problem, we got another new concept which is known as digital signature. We got a concept which is known as digital signature. This is something which is used in blockchain. I mean, it comes under cryptography, but this is the exact thing that happens. Okay, even if you create your own company, if you register for your company gets this digital signature. I created my NGO, so my NGO has its own digital signature. It has its own identity. Okay, so digital signature, if you see the conventional way, there are some certifying authorities who will provide you with this. Okay, so digital signature is used to provide the authentication to the user's identity. Okay, okay. Let me see some doubts if you guys have any doubt. Okay, so Nilesh is having doubts. When I send my message and give the digest is called the digital signature. No, not exactly. Yeah, how do you? All right, Nilesh, digest. Yeah, digest comes in a digital signature. Okay, I'll come to that. Okay, so how do you sign the message? That's the question first. Okay, now let's see. Now let's see it. Megha, this is the example you want, right, for digital signature, right? Yeah, this is what I'm going to tell you guys right now. Okay, so I'm rubbing this thing. You guys, if you want to take a screenshot, you guys can take it. This is not digital signature. Okay, I've just written it to tell you that this is the solution. Taken? Okay. Actually, digital signature is taken from the idea of asymmetric cryptography, but there's a single chain. Okay, and that chain is not. See, asymmetric cryptography is also useful. Digital signature is also useful. We both have to combine together. Okay, so I'll rub this thing right now. Asymmetric cryptography. Now I'll write the concept digital signature. I'm telling you, okay, because we have students from MBA Finance as well. Okay, so I'm making things easy. Okay, which is important to understand blockchain. Now let's talk about digital signature. Okay, so digital signature, I'll again tell a story. Always remember we have Alice and Bob only. I don't know what's the logic behind it, but in every cryptography book I have seen Alice, Bob, and villain is Oscar. I don't know what's the reason. What's the story behind this Alice, Bob, and Oscar? But they are the all they are the ones that are already taken every time. Okay, and on the other side we have Bob. No, no. Let's listen to a story again. Alice say, Bob, I want to send you a message. Bob will say, okay, let's use asymmetric cryptography. But Bob also said, okay, Alice, listen to me very carefully. Before we do asymmetric encryption, I want you to secure our identity. I want you to secure your identity. Okay. Bob will say, before sending the message, I want you to secure your identity. Secure your identity. Alice will say, How will I do that? Bob will say, same concept, create a pair of public and a private key. Alice will say, okay. So Alice will create a pair of public and a private key, EADA. Just give me a minute. There's some problem, internet problem. Yeah. EADA. EADA. Okay, I'll write it inside. I'll write it here. So wait. Alice will create EADA. This is before asymmetric cryptography is done. Here we are securing the identity. Now Alice will say, okay, Bob, now you have told me to create a pair of public and private key. Now what I'll do. So Bob will say, take a random message. It's a normal message. It's not the actual message. Take a random message. Let's say that message is M dash. That message is M dash. Okay, wait. It's not M dash. It's only M. Okay. Bob will say, take a random message M. Oh, Alice will say, okay, I have taken a random messages. Now Bob will say, do apply a digital signature. Apply your digital signature. So Alice will say now. So Bob, what is digital signature? So Bob will say, just encrypt your message using your private key. Using your private key. Alice will say, oh wow, that's something new again. Because guys, private key is the only thing on internet that is unique to everyone. So why we use this uniqueness to identify upon that? If I am a private digital signature, okay, so I'm uniquely identified by the private key. Okay, so Alice will do digital signature. And digital signature is just encryption of message, this random message using private key of Alice. Using private key of Alice. To make it large. So, sorry, I've stretched. Yeah. Alice now will say, okay, now I have created a digital signature. This is known as signing a message. You are signing a message. Okay. You guys know when suppose I have an agreement with, let's say, a person, and that in that agreement I have to pay that person, let's say, 5 lakh rupees. Okay, so I have to, how will I prove? How will I prove that I have given consent that 5 lakhs? So I will do my signature. Right? I will do my signature. So that signature proves that yes, Antave has signed this message. Okay, electronic signature, physical signature. Now we have digital signature. Okay, but digital signature is mathematical calculated, unlike we have electronic signature or physical signature. We'll come to that. Okay, so digital signature means encrypting your message using private key of yours, because private key is something that belongs to you. So you can imagine a private key with your signature. You guys will be having your own signatures, right, which you will use in your daily life. Okay, so you can imagine that signature as your private key that shows that yes, I am authenticating this message, I am signing this message. Okay, now this will be received by Bob. Okay, this will be received by Bob. I'm just right now telling how digital signature is done. Okay, before that. Okay, uh, with this digital signature, I'll write it here. With this digital signature, E of DA of M, Alice will append message as well, will add the message as well for verification. I'll tell what verification is. So Alice along with the digital signature will also send the message, the random message to Bob. Okay, Alice will send digital signature along with the message M. If you guys having confusion, I'll just remove this. I'll just write comma. So Alice sent two things now, for digital signature and the message M. Okay, now Bob will receive it. I'm doing here, okay? I'm doing here because it's the space is really less. Now Bob have two things. First is E of dA of M, okay, and then on the other side we have this M, okay, okay, all right. Now Bob will verify or decipher. So how will Bob verify? By using public key of Bob, because it is public, it is public. So how will he do decryption of this E of dA of M using public key of Bob? Up there we see it's now vice versa, right? Now we are decrypting using private public key. Now they will cancel out with each other and we'll get the message M dash. Suppose this is the message M dash, okay, because after a calculation a lot of things can be changed. Okay, so suppose this is M dash. Now this M dash will be compared with this M. They both will be compared. And if they are equal to, if they are equal to, that means verification successful. If message of the calculated message and the message that was sent by Alice, if they are same, that means verification is successful. That means this is the original Alice who is sending the message, who is not sending the message actually, but who is proving her identity. Okay, okay. Now let's see the example, and let's say Manthav wants to impersonate Alice. Okay, first take a screenshot of it. For the screenshot, I'll rub this right down, rub this right part. I'll rub this also. So suppose this is not Alice. Alice is again impersonated by Mantavve, who is not a good person. Okay. Now Mantavve impersonated Alice, said, "Oh Bob, I have to send a message." Bob will say, "First prove me yourself that you are Alice or not." Okay. But as you know, Mantavve will be having its own public and private key. So let's say EMDM. EMDM. Because it's not actual Alice, so he will not be having E and DA. He will be having EM and DM. Public key of Mantavve and private key of Mantavve. Okay. Now he will. Now Mantavve will say, "Okay, I'll sign the message." So Mantavve will do digital signature. DS is equals to encryption of message using private key of Mantavve. E of M. Sorry. D of M. I'll write it here. E of M using private key of Mantavve. Okay, private key of Mantavve. Now this will be received by Bob. Now Bob must be having an idea that, oh, shayad it must belongs to, let's say, Alice. But Bob will verify first. Okay. So, and also the appended message. So E of DM of M with the comma message M. Okay. Now Bob will do the verification. So on the right side we have E of DM of M, and here we have mem. Suppose this is original Alice. Sorry, this is original. Oh, what I'm doing here. This is original Alice. This is original Alice. And Alice will be having its own public key and private key, E and DA. Okay. Now, when Bob will do verification, the verification, so Bob will do decryption of encryption of this DM by M. Now, guys, what do you think? Bob will take public key of Alice or public key of Mantave? Public key of Alice. Because see, public keys are available on internet. So Bob will see this public key, not Mantave's public key. Okay. So Bob will try to decrypt or verify Mantave's private key with Alice public key. And this will not be calculated, and there will be a message M dash. Now it will be compared. It's like very gibberish. It's not because there's no the proper key to decrypt it. So we'll get a value which is not equal to message n. So now we will do the comparison. They will be compared and they will come out to not equal to. So verification unsuccessful. Verification unsuccessful. So Bob will know, oh my god, this is not actual Alice. This is someone else who is trying to impersonate Alice. Someone is trying to impersonate Alice. So this is what digital signature. So in a very short, digital signature is just your private key. Digital signature is just your private key. Okay? Digital signature is just your private key. Okay? I'll repeat again. Digital signature is just your private key. Okay? I'll rub this thing and I'll write it in big. So you guys will never forget. Now your whole cryptocurrency works on this digital signature only. Okay, I'll tell you why. So digital signature is just the user's private key. Take the screenshot of it. Taken? Okay. Now let's see some doubts. If you guys are having any. Yeah, Khan. Yeah, Yusuf. Private key is the unique key that belongs to user only. Okay. My voice is lagging. How is it now? Ananya, assessments will be there. Okay. We'll update you soon. And before assessments, there is a final test as well. It will be on the last day. Sir, please quick revision of private key and public key. Using asymmetric cryptography. Okay, I'll tell. Listen to this very carefully. Suppose uh, Kunut, okay, Kunut, okay, or let's say I'll tell you Mr. Khan, okay. Suppose Mantev wants to send a message to Mr. Khan, okay, okay. Now I will ask Kunut, please give me your public key so that I can encrypt the message. Kunut will say why? Because I will say, see, the public key can only be decrypted with your private key, and private key doesn't belong to anyone else. So Kunut said, yeah, that's a good idea. So Kunut will send me his public key. Okay. All right. So now Mantav will encrypt the message using Kunut's public key. Okay. Now once else they send the message to Kunut, Kunut can only Kunut. Okay. Only and only Kunut can able to decrypt can decrypt that message because Kunut owns that private key that breaks or that decrypts the public key of Kunut only. Okay, so that's a relation between a public key and a private key. Public key and private key are computationally together. They can, if they have to separate something, you have to use another. Okay, so they are computationally linked to each other. So that's a concept of public key and private key. Public key you give to everyone, so anyone can encrypt the message. But private key belongs to you only. Private key belongs to you only. Okay. 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 All right. So that's what asymmetric cryptography is. That is what digital signature is. If you guys understood what digital signature is, okay. I'll ask you a question. What do you think is the difference between electronic signature and a digital signature? What do you think? I'm a lawyer, so I'll tell you a case of that. Okay, it's a very interesting case. When I was learning contract act, okay, so there was a very interesting case. So, but before that, I want to know from your side, what is the difference between electronic signature versus digital signature? Okay, physical signature versus electronic signature versus digital signature. Let me see what you guys think of it. Then I'll explain. Photo of signature? Yeah, Nilesh. Okay, but explain more. Explain more. I want more explanation. Okay. Anyone else? Anyone else? Only Nilesh is saying. Electronic signature is a kind of machine where we sign a thumbprint, and digital signature where we sign a device using hand or pen. Not exactly, Sohas. Not exactly. Anyone else? Maybe e-signature is a scanned copy of physical signature, or digital signature is more secure. Partially right. Digital signature is uniquely given in USB. USB? What USB? Electronic and physical signatures are done by us. Yeah, that's 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 right. That's right. Okay. Okay. Now I'll tell. You know, there was a case. But sir, what type of data is encrypted? Our messages are encrypted. Okay. Our messages are encrypted. Our identity is encrypted. See, digital signature concept is to just to verify that this person is liable for its activity. Suppose if I send someone a very okay, a very explicit message or anything. So how will the court of law will prove that Mantav is guilty? Okay. So digital signature proves that thing. Okay. Yes, Mohammed, you are right that electronic and physical signature doesn't require encryption. That's right. Okay, now I'll tell. See, there was a case. I don't remember the case. Okay, so there was a case where there were two parties, one from India and one was abroad. Okay, and they had an agreement on Gmail. They had an agreement on Gmail. Okay, and the person was in India. So they had a deal of something. Let's say he will transfer the money, and there would be a shipment coming from abroad. So that was a case. Okay, now the everything was done on everything was done on email. Okay, yeah, everything was done on email. So what this person did, person just just did a signature and scanned a copy to it and send it over email. Okay, now what happened was that company didn't send those shipment and received money from him. So that person sued that company, okay, into the court of law. And then that company said, sir, this is not the right way of doing the agreement. This is not the right way. But what court said, the court said that every kind of agreement, if both the parties are consenting to each other, okay, if both the parties are consenting to each other, then it will be treated as a legal contract. It will be treated as a legal contract. So from that time, sorry, after that time, court said that every kind of signature, if you just write, suppose this is my signature. This is electronic signature. Okay, if I write my signature on a piece of paper, take a photo of it, that is also electronic signature. My thumbprint is also a electronic signature. My iris scan is also a electronic signature. When you guys just click on terms and conditions, I agree, you guys click on I agree, right? I agree in every other website. So that is also electronic signature. So everything that provides your consent is your electronic signature. Okay. But when we talk about this digital signature is based on mathematics. It's totally based on method. Like someone said, it requires encryption. Encryption requires mathematics. Okay, so digital signature. See, both work is to ensure that someone is responsible for this. Okay, someone is providing their uh, proof that yes, I am responsible for this. Both work are the same. I mean, digital signature and electronic signature, but digital signature is much secure as it is based on mathematics. And second, yeah, it's based on mathematics and it's secure. So that's the difference between electronic signature and digital signature. So Yamuna said electronic signatures are a broad category that encompasses any electronic method of signing. That's true. While digital signatures are a specific type of electronic signature that uses cryptography, okay, to ensure the authenticity and integrity of the document and signer's identity. Exactly. Acha, now tell me what's integrity. What's integrity? What is the difference between confidentiality and integrity? Those who belongs from cybersecurity background, I think they can answer this question. What is the difference between confidentiality and integrity? See, they are normal words. We use them in our daily life. But what do you mean by it? What do you mean by confidentiality and what do you mean by? Sorry? Nilesh, I don't understand. Okay. Tell me. Who argues integrity? Hmm. Yeah, we can say the data should be unchanged. Yeah, Yash is right. Only particular user should get the data. Okay. Integrity means the data should be unchanged. Integrity means ensuring data is accurate. Yes, that's right. Confidentiality means privacy. That's right. Confidentiality means a data or information which is extra secure and can only be accessed by few group. No, Sohas. Confidentiality means protecting and sensitive information from authorized. Yes, showing only authorized individual can integrate on the hand and refers to the accuracy, completeness, and reliability of the data. That's correct. Ensuring it hasn't been altered or tampered without authorization. That's right. Rishika, and other data is sensitive. Okay. Who it is supposed to send to only received by them. Exactly. That's what confidentiality is. Integrity means the information should be right when it's exactly. Priya said in a very easy manner. Integrity means the information should be right. It should be accurate. It should be complete when it is received by receiver. Okay. Yeah. Right. Right. Now I'll show you with a diagram. Suppose suppose again, I'll take the example of Alice. This is Alice. Okay. And on the other side, we have Bob. Suppose Alice is sending message hi. Okay. Message is sending hi. Suppose there's a person who is just seeing this message. So that is known as breach of confidentiality. Breach of confidentiality. That means the data that was only for Alice and Bob now is accessible with the third person. That is known as breach of confidentiality. Breach of confidentiality. Okay, breach of confidentiality. Here, confidentiality is not maintained because this person can also see the message. That's why we use cryptography to hide this message. So, but if it's hidden, then it's confidential. That's why we said cryptography provides confidentiality. Now see what's integrity. Like Priya said, it should be right, it should be complete, it should be accurate when it is received by the Bob. So suppose this is Alice. And Alice has a message, hi. Okay. Now this message has to be sent to Bob. Okay. But suppose this message is not directly going to Bob. What's happening is this message is first going to, this is the original path of the message. But suppose this message is going to first, let's say, a hacker. And hacker is changing this message from hi to, let's say, hey. And then this hacker is sending this message to Bob. Now Bob will receive the message hey, which is not the actual message hi. So as Priya said, the data should be, when it's received, it should be right, it should be accurate. But you can see, guys, here Bob is getting a new message. So that is known as breach of integrity. That is known as breach of integrity. Okay, and this is also known as man in the middle attack. Man in the middle attack. Man in the middle attack. MITM. Man in the middle. Man in the middle attack. Okay, MITM. Man in the middle attack. I guess most of you are aware of this. Okay. You guys know what is man in the middle attack? Because you can see it is attacking. It is changing the message. Okay, so that's why man in the middle attack. Now, how do we provide this integrity? How do we provide this integrity? So the answer is hashing, which we'll see after 10 minutes. Okay? Hashing is used for maintaining integrity of the data. And I'll tell you with what I have done, what I have seen in my real life when I was working with when I was working with cyber this hashing is really, really important, guys. It's really important, not just for maintaining the integrity, but suppose if there is a criminal, and if that criminal has to be persecuted in the court of law, if you want to make that criminal behind the bars, then this hashing plays a vital role. Okay, so I'll tell you with what I have studied, with what I have seen in my internship during in when I was working with NCFL Delhi. So that's really, really interesting. Okay, so we'll meet after 10 minutes. Okay, and then we'll discuss what hashing is. Okay. NCFL is National Cyber Forensic Lab. It's in Delhi. Okay. All right. Now let's meet at 8:15. Okay. Okay, let's start. Sorry, a bit late. All right. Now let's start with hashing. Okay. So hashing is known as a digital fingerprint of the data. Like we humans have unique fingerprint, right? Similarly, every data has its unique hash value. Okay. It has its own hash value. And why it is really important? For that, I'll take an example. Not an example. Yeah, I'll take an example. Okay. I think my screen is not visible. Yeah, it's not. It's widely used in digital forensics. It's widely used in digital forensics. First, I'll tell what hashing is. Okay. Hashing, hashing. Suppose there's a value known as, suppose I am writing, I am Mantavya. I am Mantavya. And if I put it into a hash function is the function which is used to calculate a hash value. Okay. Suppose I used a hash function to hash I am Mantavya. Suppose hash value is ABCD. This is the hash value. This is the hash value. Okay. Now, guys, in encryption, if you guys remember in encryption, it is a reversible process. It is a reversible process. That means I'll write it here. Suppose there's a message again, I am Mantavya. Okay. And if you are encrypting it, if you are encryption, okay. If you are if you're doing encryption, okay. Suppose it gave a value, let's say, XYZ. I'm just saying an example. So this XYZ can be this XYZ can be decrypted again with using decryption. Using decryption, we can get the actual data back. We can get the actual data back. So we can say that encryption and decryption is a reversible process. It's a reversible process. You can get the actual data. Okay, you can get the actual data from decryption. Okay, so there are reversible process. You can encrypt it and then decrypt it to get the original data. But you cannot go back. You cannot go back to the original value inside the hash in the hashing concept. Hashing is known as irreversible process. Irreversible process. That means if you calculate a data's hash value, you cannot go back to the original data. You cannot go to the original data back from the hash value. So it is irreversible process. It is a irreversible process, and it's asked when I was. I'll tell you when my college. It's the time of placement, so we got the right company, and that time they asked this question to me: what's the difference between encryption and hashing? So that this is the first difference, that encryption is a reversible process. You can get back the original data, okay, but in hashing process you cannot get back the original data. So that is what it is known as irreversible process, or it is known as one-way function. It is also known as one-way function. Encryption and decryption are two-way function, but hash function is a one-way function. Again, the same meaning. You cannot go back to the original data. Okay. Now, where it is used? Now, where it is used? It is used for integrity. It is used for integrity. And why integrity? Suppose there's an office, and in their office I have my fingerprint. Okay, that only this office can only be unlocked with Mantavya's fingerprint. Okay, now let's say if another person tries to do it, if another person tries to enter my room by entering his fingerprint, it will decline it. Okay, it will decline it. So similarly, it is used in this hash process, and I'll tell you how it's done. Have it have takes taken screenshot of it? Please take screenshot of it. Taken? Okay. So hashing says that if you calculate a data, I mean if you calculate a hash value of a data, okay, and if you calculate a hash of a data, and if suppose if there is a bit change in the data, bit change, for that I'll show you with a practical example. I'll share my entire screen. Wait. Encryption, I mean cryptography, or this hashing part only. He's not replying right now. Okay, for hashing now, yeah, it's just started. Okay, don't worry. I'll wait. I'll share my entire screen now. I think my screen is visible. So what I'll do, guys, first I will write a data here. First I'll write a data. Suppose the data is I am Mantavya. Okay, let's say I am Mantavya, the killer. The killer. Okay, suppose this is a evidence. Suppose this is a evidence that a investigation officer found it on a site, on the crime site, inside a computer. So this is inside a computer. Suppose this is the computer. This is the computer. Okay. And inside this data, they got a evidence which is known as I am Mantavya the killer. This is the original evidence. The original evidence. Now, guys, what happen is if you want to make someone behind the bars, you have to secure this evidence and present it inside the court of law. You have to present it inside the court of law. Then judge will check its accuracy if the data is accurate or not, if the data is being tampered or not from its acquisition till it reaches to the court of law. I'll repeat again. From the time when it got acquired. Okay, suppose it acquired on, let's say, 5th January. So at the time it was acquired and the time it was presented inside the court, let's say on 10th January. So between these 5 days, the data should be accurate. It hasn't been tampered. So this is, we have to, I mean, all the the forensic expert, they have to make sure this data is safe. So they can directly present it into the court of law. Okay. Okay. Now suppose this data was retrieved by officer 1. Officer 1. Now what officer will do? Officer will calculate a hash value of it. Hash value. Okay. Now let's calculate a hash value. For that, is my screen visible? Yeah, it is visible. So I'll open a hash online. Okay, you will find various websites. My favorite is this one. My internet is a bit slow today, or what's happening? Am I audible, guys? Voice breaking? Okay, how is it now? Just let me know. Is it breaking? Is it fine or is it breaking? Madhav, I'm not getting. It's clear? Okay. That's good. All right. So what I'll do, I'll write it here. I am the officer right now. Mantha is the officer, Mantha is the killer. So I'm both. Okay. So I am Mantavya, the killer. Now I'll calculate this. I'll calculate string values. I'll calculate the hash value. Now all these are the hash algorithms. These are all the hash algorithms. Bitcoin uses this one, SHA-256, SHA, secure hashing algorithm 256. Now I'll copy this data. Okay, now I'll paste it here. So this is the hash value that we got. This is the hash value that we got. How do I make it this? Yeah. This is the hash value. Oops. This is the hash value. Oh, yeah. This is the hash value that the officer received. Okay. Okay. Now suppose when this officer gave it to another officer. So officer will be getting this file again. Okay. I am Mantavya, the killer. Suppose between this transfer data, the data got hacked. The data got hacked. Okay. The data got hacked. Suppose instead of Mantavya, somebody wrote, let's say Alice. Somebody wrote Alice. Okay. Now this officer 2 will calculate the hash value. Now we'll calculate it for Alice as well. I'll calculate the string values. I'll copy this SHA-256 and I'll paste it here. Now you guys can see the hash values entirely change. So when officer 2 will compare the original hash, this is the original hash. Okay, this is the original hash. With the new hash, they are not same. They are not same. So this is why we can say the integrity is being breached now. Okay, now you cannot, I mean, not, we cannot, the court will not accept this evidence. It will not accept this evidence. Alice will say, sorry, the court will say that this data is not accurate. It's being tempered. Okay. Okay. Now you guys must be thinking, sir, if you change the whole data, I mean from Mantavya to Alice, it will automatically change. But what if I change a bit of information? For example, suppose instead of Alice, I have written Mantavya only, but the only difference is from capital M, I just did small m. From capital M to just small m. Okay. So let's see what it will result. Mantavya. Small n. Now, if I calculate it, if you copy this and if you remove this old one, if you paste it here, see the data is again changed. That means a hash value is so important that a bit of data is changed, the entire hash value gets changed. Okay. If a bit of information is changed, the entire hash value gets changed. Okay, so that's why this hash value plays a vital role if you want to make someone responsible. Okay, because it provides that this data is accurate or not. All right, so this is what hash value is. This is the importance of hash value, and that's why if you read Information Technology Act of 2008, or if you read the Evidence Act, okay, so they have mentioned a hash value as an important factor. Okay, so digital forensic, we are always told that how to secure the file and the hash value. Okay, so for that I'll tell you guys. So we apply a write blocker. Write blocker means it's a software which you apply on, and let's say on any let's say Word file, and let's say to any application. So nobody can now write in the data. Okay, nobody can change inside the data. So this is how we make the data secure, by applying the write blocker. Write blocker. Write blocker. Okay, we apply the write blocker. So the data is now blocked for writing. So nobody can write the data. So the data is preserved here. Okay, nobody can change I'm Mantavya the killer. All right. Now this data has to be maintained till it reaches to the court of law. Suppose from officer 2 to, let's say, officer 3, then let's say officer 4. So for every chain of custody, this is known as chain of custody. First it was in the custody of officer 1, then in with the custody of officer 2, and let's in next to officer 3. Okay, so this chain of custody has to maintain, they have to preserve this hash value in the entire file. So that's something which is really, really important. Okay. Okay. So this is the concept of hash value. And one more important concept of hash value. Just take the screenshot of it. Just take the screenshot. Or wait, don't take. Here I'll write. Here, I'll write. Um, a bit of information, a bit of data, bit of data, a bit of, sorry, a change in, a change, a change in a bit of data can change the entire hash value. Okay, a change in a bit of data can change the entire hash value. Now you guys can take the screenshot. I guess you guys have taken. Okay, now this question is always asked, what's the difference between encryption and decryption? So first difference we have already seen, that encryption is a two-way function, or it's irreversible. Reversible, and on the other hand, hashing is a one-way function or irreversible process. Okay, so now if I differentiate between encryption and hashing, so first difference we have seen, it's a two-way function. Okay, or it's reversible. On the other hand, hashing, it's a one-way function. So Madhav, one-way function means that if you encrypt a data, you can decrypt it and get the original data back, right? You can decrypt and you get the original data back. But in a hash value, if you calculate a hash value of a data, okay, you cannot go back to the original data. Okay, you cannot go back to the original data. That's one of the benefits of hash value. Okay, so no one can check hash and try to calculate the original data back. Okay, so that's the benefit. Second point, it always produces, not always, uh, it produce, oh, it's not rubbing. What's happening? Yeah, it produces variable length output. That means it depends on the size of the message. If the message is size, the output is of the same size. If the input is large, the output will be large. So it produces variable length output. Okay, suppose a two letter high. So the encrypted word will be KL. So it's a two word only. Suppose if a message is bigger, so the output will be bigger. But in hash process, it doesn't matter. It doesn't matter what's the size of the message. If it's a two letter, if it's a single letter, or it's 100 word, it's 100 word sentence, doesn't matter. The output will always be the same. So again, nobody can actually know that what's the actual data behind it. If it's a small data, it's a large data. I'll show you. First, I'll write it. Second point, always produce fixed length output. Fixed length output. Okay, always produce fixed length output. Now I'll show you guys here. Suppose I'm just writing I'm just writing okay. Now if I calculate hash value, okay, now you can choose anyone. I'm choosing MD2 right now. Okay, I'm copying it and I've opened a notepad. I'll write in notepad. Okay, suppose I'm writing it and suppose the data, what was the data? IM. Okay, now suppose the data is really large. IM month away kilo. Okay, and blah blah blah. Okay, now if I calculate the string value again, if I click on this, if I copy this, if I now paste it here, you guys can see it doesn't matter, the size is always the same. So I am Mantavir kilo blah blah blah. Okay, so the size is always same. So you cannot interpret that this message can be of a single letter also. It could be a sentence for 100 words as well. The output will always be the same. Okay, and that's why this hashing is used in digital signature as well. When I told you no random message, so instead of a random message, they take this hash value because it's smaller in size. It is smaller in size. Well, it saves a lot of space. Okay, so that is known as digital signature standard. Digital signature standard, where instead of M we take this. I mean, instead of random message, not instead, but we take this hash value as the random message. Okay, I am ante the killer blah blah blah, or I am the output is same every time. Sorry, the length of the output is same every time. Okay. All right, so that's the concept of hash value. That's the concept of hash value. It is used for integrity. Okay, now now take the screenshot of it. Take the screenshot. Taken. Okay, now remember yesterday we discussed two questions. First question was how transactions are done. How transactions are done in blockchain, right? Okay, and second question, how blocks are connected to each other. Okay, so these are the two questions that we were discussing yesterday, and I told you once we complete digital signature, once we complete with hashing, okay, then we'll discuss how transactions are really done and how blocks are connected to each other. Okay, now let's discuss how transactions are done. Okay, very important, very important. Just let me check if you guys have any doubt. Really, it is known as hash function. Okay, it depends. There are various ways of calculating. Sir, in those cases, like you explained, it's okay if they are not gonna know the original message. Exactly. It doesn't matter. It doesn't matter if you know the original message. What matter is if the hash value should be same. That's right. Because various places you don't declare the message. Okay. You guys know how your passwords are stored in a centralized system. You guys know about it. Let me just discuss this before. Okay, so your password. Suppose a password is xyz@1234. Suppose this is my password, my Facebook password. So Facebook, Facebook. First, it will convert into a hash value. Okay, and then this, suppose this hash value is ABCD. Now this ABCD will be stored in Facebook database. Facebook database. Okay, so always remember, they don't keep your direct data, sorry, they don't keep your password directly with themselves. They actually store this hash value with themselves, because this is what it matters. So now when you try to, when you try to, let's say, log in, when you try to log in, so what will happen? Suppose this is the login space we see. Okay, we have username and we have this password. This is the password and this is username. This is username and this is password. So when you write your password here, X, Y, Z at the rate 1234, first it will calculate the hash value, which is ABCD. Now suppose this is the centralized database of Facebook where all the password is stored. So they having your this ABCD. Now they will compare this ABCD with the ABCD which is residing in there. If they are equal, then you are able to log in. So they don't hold your password, they hold your hash value with themselves. Okay, otherwise, I think you must know about this, and I guess in engineering we have done this practice, that if you try to log in with your hash value directly, it will be calculated. Okay. I have read about this, but I don't think so it will work. What do you think, guys? Do it and let me know. This is your work today. Okay, so it matches with your hash value, which is already stored inside their centralized database. So this is how they check. They don't store your password with themselves. Okay, that's something really important here. Okay, so that's why, like Maitri said, we don't actually have to store data somewhere. Only this hash value matters in the last. Okay. Now, let's discuss the cryptocurrency part. How does exactly this thing works? Yeah, Madhav, if even a tiny change like one character flips the whole hash. Exactly. How do systems still verify data engraved without getting confused? Again, Madhav, the same way they store your hash with the same data. Now, suppose instead of XYZ, I mistakenly wrote WYZ at the rate 1234. It will create a hash. That hash will not match with the hash which is inside the database. Okay, so it will say wrong password. Okay. See, systems are not confused. We humans store it somewhere, the original hash, and then we compare it with the old hash. We calculate a new hash and then we compare it to the original hash. If they are same, then we can say no data change. If it's it, so we can say, yeah, the data, there's been a data tampering. Okay. I guess it's clear now. Okay. Nilesh is asking. Okay, no, Madhav. So sir, hashing is one way like blending fruits into. Yeah, exactly. Exactly. You guys can see Madhav's uh, explanation. It's a really good explanation. If you blend fruits into smoothie, you cannot get back fruit from smoothie bag. So that's what a hash value is. Why encryption is like locking data in a box with a, exactly, Madhav. Very good, Madhav. Okay. Nilesh is saying, so decrypt and then calculate the hash, and when it matches, mean it is from correct person and without temper. Yeah, see that message has to be something. Okay, but we have to hide that message as well. So just keep it a hash value so nobody will understand what the message is. You are talking about digital signature standard, right? Digital signature plus hashing. Yeah. So this is why we use it. How the data can be fetched from the hash value. Yusuf, I get you got the answer when I told you about this Facebook example. Facebook store this hash value of your, and then they will verify when you enter your password again. Okay. How is hashing used for digital signatures? Yamuna, okay, I'll tell, no problem. If you guys have seen it or not, आप लोगों ने I think most of you understand Hindi. Okay, but I'll say in English only, no problem. Suppose this is Alice, and on the other hand, we have Bob. Alice and Bob. Okay, Alice will apply digital signature. She will be creating a pair of private and public key NDA digital signature, which is sorry, why it's not rubbing? Yeah, encryption of message using private key of Bob, Alice. Now it will send to Bob, but she will append a message as well, right? EA of DA of M, and nobody asked this question to me, sir. This message is open. Sir, this message is open when we are appending it, comma mapped. This is open. Anyone can see it. So we have to secure it. So if we want to secure it again using encryption, so it will be a large process. I'll tell you what experts thought, but they declined this idea. And then they got the concept of hash value to use it here. I'll tell it here. Okay. So I'll rub it right now. Now you guys see that message is open. So we have to encrypt it again. So Alice will say, Bob, I have applied my digital signature, but the problem is, Bob, that the message that I will append with my digital signature for your verification, it will be open. So Bob will say, okay, then again encrypt it using my public key. So Bob will create his again public key and a private key. So now Bob will share this to Alice. Okay, Bob will share this to Alice. So now Alice will again encrypt. So encryption of this digital signature E of DA of M using public key of Bob. Okay, oh, sorry. It's incomplete. Sorry. Just give me a minute. It's incomplete. So instead of just it, what we are doing is we are appending a message as well. Comma, I'll write comma for everyone. Not append. Comma M. So now you guys can see now it's hidden. This message is now hidden. Inside this encryption, now it will be sent to Bob. It's like, guys, now listen to this very clearly. It's like two boxes. One, there's a small box. You have wrapped it, and then you have placed it inside a bigger box, and then you have closed that box also. Now there are two boxes. Okay. So what Alice is? Alice first close the small box and then put it inside the bigger box, and then Alice close the bigger box. Okay. Now once Bob will receive it, what Bob will do? Bob will open the first box, and then the smaller box. Okay. This is what Bob will do. So when Bob will receive this thing, E of EB of E of DA of M with M. Okay. Now to decrypt this, what Bob will need? His private key. So let's do it. Let's decipher it first. So it will be decryption of with the private key E of EB, E of DA, M, M. So it will cancel out. We'll get E of DA, M. Okay. And with this message M. This is comma. Okay. Now you guys know the entire process, the digital signature verification. Okay. So this was the first way. But you guys can see encryption requires mathematics. In mathematics, computations are really large. So what you guys are doing is you are encrypting twice. So it will take a lot of space. And you have to choose cryptography in such a way because everybody is sending a message to everyone, right, around the world. So we have to make this data small. So it's not a good approach to encrypt the data twice. So that's why they came up with a solution that keep this message as a hash value. So if it's open, don't worry, nobody can see what actually this thing is. Okay. So what a new approach is, not this, it's not a new approach. Again, it's a very old approach. So what they are doing is they are taking a message M, and is taking a message M, and then using a hash function, creating a hash value, let's say h1. Now they are just applying a digital signature, which is encryption of h using private key of Alice and then sending it. So now they have E of DA of h. Now with the h1, sorry, it's h1, right? Now h1. So now if it's open, we don't have to worry about it if it's open because nobody can understand what hash is. So now they have made the process really easy because hash value, suppose the message is very large message, 100-word message. 100 word message. But if you calculate a hash value, it's a small. I showed you. It's a small thing. It's a small thing, right? So that's why now this is known as digital signature standard. Digital. This is what world is using. Digital signature standard. This is known as digital signature standard or DSS. DSS. Okay. All right. Yeah, Yamna, you can imagine that in university everyone is assigned with a roll number. But writing a roll number, you can get the original data, mantave, name, or let's say my hometown and everything. Okay. Thank you, Yash. So yes, Rituk Reddy, the hash length is always the same. I showed you, right? See, I have the data here. If you guys can see on my screen. When I wrote IM and calculate the hash value, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh my god, it's really large. Let's say 30 letters, 30 alphanumerical string. But when I kept the data large, I'm onto the clear the blah 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 blah. Again, the data was same. The hash value output was the same as we have seen in the IM. I mean, it's not the same. The length is same. Are you getting me, Ritwe? Okay, Karthik. So digital forensics is it's a field. It's a field of cyber. You can say cyber security. It's a field of law. Where? What do you mean by forensic? What do you mean by forensic? It's a methodological process, okay, where you acquire the evidence, okay, you collect it, you investigate it, okay, then you extract the data from it, and then you finally present into the court of law, because that's the final step into the court of law, so that you can make a person liable. Suppose there's a criminal, so you can make that criminal liable for its activities, for its bad doing, and make that person behind the bars. Okay, so that's what digital forensics is. Okay, we have DNA forensic. Okay, we have a lot of field. I think we all have watched CID. Okay, so CID forensic, we have seen forensic there. So that's forensic. When you talk about digital, so it's about computer forensics. Okay, it's about disk forensic, memory forensic, everything. No, Suhas, it cannot take. Instead, AI and blockchain can work together to provide more reliable data. Okay. Madhav is saying mostly centralized system got hash and salt passwords. But if the database beta, yes, exactly. If the database is hacked, it's the problem. That's why we don't want centralized system. That's why we are reading blockchain. Okay. Isn't the hacker still able to brute force? Yeah, exactly. They can easily do it. They can easily do it. They will just apply permutations and combinations, and they can break these big password. Or like it depends on attacker, or you say the hacker how good he is, kind of like. See, it's all depends on how intelligent that hacker is. Okay, because when I was doing my work in crypto forensics, okay, so people did mistake. Okay, people most of the time they keep their private key online, so that's the biggest mistake. So we are able to retrieve that. Okay, so it depends. We have to apply forensics and various things. Okay, we have to apply some password breaking mechanism, like one is brute force. How many digits are in hash? See, it depends. Okay, it depends. Like I show you here, all these algorithm size are different. See, it's written here 16 length. Okay, 60 length is 16 bytes. 16 bytes. Okay, it's 28 bytes. All right. Let's calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's bigger than. So it depends. These are all the sizes. 256 mean 256 byte size. 384 byte size. Okay, so you can see these strings are bigger. These strings are bigger as compared to these strings. These are really short, but these are really big. See how big they are. Okay. Uh-huh. Okay, caste certificate just says it digitally signed and does not need verification. Mohammed is asking, sir, when we download certificate document from the government organization like caste certificate, etc., it says it's digitally signed and doesn't need verification. How does hashing work here? See, Mohammed, if you talk about the DigiLocker, they have the same concept. We don't have to actually share our data. If see, DigiLocker is actually it's already a verified place. So if they calculate a hash value, okay, and if a company is getting it, so they can compare. Yeah, the hash value is right. That means this person is genuine. There's no such thing. That's what we have to prove, right? That we are genuine without revealing our data. Okay. Ekanta, and what are the Bob to explain in simple line? I'm not getting you, Ekanta. In AWS and Microsoft Azure uses blockchain. Yeah, Sai. Now they are using because they are something which is known as private blockchain. So private blockchain needs a storage, so they use these AWS. Exactly, Kunur. They don't have to understand. They just have to verify that this message is coming from Alice or not. You guys, you have seen it. We just compare am with the message. Okay, I'll show you here. Okay, yeah. In this example, you have seen. Again, I'll tell you. I told you if a bit of information is changed, the entire hash value changes, right? So suppose we don't have to actually see what's inside the hash. So when Bob will do decipher, I mean when Bob will do verify, so it's like E of DA of H1. Okay. Sorry, decryption. We have to do decryption using what? Public key of Alice. EA. So when they'll cancel out, they will got H1. Now they will just compare these two things. If the hashes are different, if the hashes are different, if they are not equal to, that means verification is not done. So that's what we required. We actually don't need to have a message here. What matter is that hash should not be changed. Okay. Sir, if we are encrypting and decrypting our message using asymmetric cryptography, then why hashing is required? See, I don't know what's your name. See, hashing is for integrity. If a data is changed, if a data is changed, okay, we can actually get to know about a data is changed. Okay, but encryption is just for hiding the message. It's not actually providing a verification if the data is being secured or not. I mean, not secured, but if the data is changed or not. Okay, suppose somebody try to decrypt that. Okay, and they decrypted the sorry they changed the data, so hash value will also get changed. Okay, so both are different. Hashing is for maintaining integrity. Okay, to verify if the data is changed or not. All right. Nilesh, can you type it again? I'm not getting you. Thank you, Amina. Okay, it's already 9. Okay, I'll tell you one thing. Okay, I'll tell you one thing. And take your 5 minutes more. So now we have seen what digital signature is. Okay. Now when we talk about what coin is, what this token is, we actually see the value behind it, right? Because world runs behind value. Oh my God, it's of worth of crore, it's of lakh of crore. But what's important is, what's really important behind this coin and token concept is about ownership of the data. Ownership of the data. If you don't look, suppose if I have one Bitcoin, so if you don't look the value behind it, what this one Bitcoin represents, it represents ownership of someone, that it belongs to someone. And where is this ownership coming from? Digital signature. And where is this digital signature coming from? Private key. That means your coin is nothing, just a representation of your private key. Coin is nothing. When I said, you guys can see my diary. You guys can see my diary. It's, yeah, I think if I show you here, this diary is having a Solana's private key. I mean, I am holding 16,000 worth of Solana. It's in point. I don't remember exactly. So the private key is written here inside my diary. That private key is my coin. It shows my worth. It shows the Solana's 16,000 worth. Though it belongs to me. So if you just forget the value behind the token or coin, the token or coin is actually for ownership, to prove the ownership of someone. Okay, so now you guys can imagine, not apart from cryptocurrency, it has various options where someone has to provide their ownership of the data. Okay, suppose if I take an example here, and I told you that Karnataka government has implemented blockchain for land registry system. I told you what's the reason, because in India we have a problem of land ownership. One of my neighbor, he was telling me that a guy sold a piece of land to 10 different people. Can you guys imagine? So all these are the concerning things in India, if you talk about from the perspective of land ownership. So what is happening is, suppose this is a piece of land. This is a piece of land. This piece of land is converted into a token. Let's say token of land. This is the name of the token. That's a token of land one. Now this token of land one is present. Let's say it's given to Alice. Now Alice has written this token of land one. I mean the private key. Actually, it's a private key. It's a private key if you see the raw data. So Alice will write this private key in his diary, in her diary, or let's say anywhere. So this token of land represents the ownership of Alice in a decentralized network. It's not on a centralized system, because if it's on a centralized system, anyone can tamper. No, it doesn't belong to Alice, but to, let's say, anyone else. Now, if let's say a person, now this information is recorded on blockchain. This information, suppose this information, token of land one, is stored inside this information. This block. Now I told you blockchain is transparent. So this person can verify the land ownership by looking at the blockchain, that is this land it previously is belonged to someone else or not. So this is how a person can able to get to know that this land is right now not owned by anyone, or is there any owner of it. So they are making everything transparent. They are making everything transparent, the Karnataka government, so that everyone can verify the ownership of a land. But proof, listen to my words carefully. Proof of this land, that this is owned by Alice, belongs to Alice only in her diary. Are you guys getting me? So if you don't look at the value behind a token, so token first priority is to provide the ownership of the data. Are you guys getting me? So now I guess I guess you got the idea how transactions really work. So this is a transaction. Alice is getting a land. Okay, Alice is buying a land, and Alice is getting a token. So it's a transaction. Okay, okay. Any doubt? Thank you, Devdatta. Thank you. It really means a lot. Are Madhav, not a problem. I'm here to answer everything. Alice, the killer hash value can to increase in future. No. Hash value cannot be cannot be increased. I told you it's permanent. Okay. Thank you, Madhav. Thank you, Devrita. Okay, really means a lot. All right. So I guess covered a topic, which is why what is a coin actually? Coin is just a private key. It's just a digital signature. It's just something that proves our identity. Nilesh will do that. We'll do it. Okay. Now next week we'll do, because there are a lot of concepts that I have to tell you guys about blockchain. Okay, there are a lot of things. All right, so we'll have to cover everything. See, smart contract coding. If you guys know what coding is, okay, okay. When you talk about the smart contract coding, it's really easy. You guys can do it. Understanding concepts are really important. Okay, but yeah, we will be working. We will be working. Okay, hands-on activities on hands-on activity. Okay, so don't worry. All right, but first we have to understand what this technology is. Okay, all right, guys, so I guess we are good to go. Good night, everyone, and let's meet tomorrow.
Okay, guys, we'll see you tomorrow. Thank you so much. Bye bye.